This is the seventh in a series of film reports covering the techniques and innovations employed in the production of the various F-111 aircraft. The F-111A, F-111C, F-111E, F-111D, and the FB-111A. Recently introduced to the F-111 manufacturing process at the Fort Worth Division of General Dynamics is a bank of 4 Datex numerically controlled core milling machines. This equipment is the most advanced of its type, now being used in the aircraft industry. The machines are controlled by perforated computer-type tape, which is developed by a digitizer head fastened to one of the cutting headways. This digitizer traces a simulated part pattern and converts X, Y, and Z motion into a playback tape. The perforations in the tape are then read by the control unit and are translated into electrical commands which position the machine cutting head. The work platens are loaded 2 at a time. Parts to be milled are lowered from a semi-automatically controlled overhead conveyor line. As one set of beds is being made ready, the machining process can be continued on another set of beds, while finished parts are being removed from the third set. The 2 synchronized cutting heads on the Datex will machine 2 parts to identical dimensions, cutting both on forward and return strokes. Operating on numerical control, the machine cuts compound contours of the honeycomb core material in sizes of up to 4 feet by 40 feet. The machine can operate at speeds of up to 300 inches per minute. The tool head cuts the core material to a tolerance of plus or minus 5 thousandths. The high versatility of the Datex core milling machines, their ability to cut 2 parts at once, the automatic, semi-automatic, and manual modes of operation, the compound contour milling of complex parts, the ability to program tapes automatically at the machine, all under the direction of a single machine operator, have proven to be important additions to the F-111 manufacturing capability. The FB-111 final assembly line has been completed during this reporting period. This assembly line is located in the General Dynamics Fort Worth main factory building in an area called the 120-foot bay. 15 assembly and work fixtures have been installed and are ready to receive the FB-111 aircraft. 3 of the FB-111As are now in the line, and 6 aircraft are expected to be in the line within the month. The 3rd production configured FB-111A strategic bomber was rolled from the production line shortly after the close of the reporting period. It is now in field operations, being prepared for flight testing. This bomber version shares the same basic fuselage as the F-111A tactical fighter, but there are several important configuration differences. The wingspan of the FB-111A is 7 feet more than the span of the F-111A. Having longer wing tips, the wheels and brakes are larger, and the landing gear has been strengthened to allow greater gross takeoff weights. The engines are the TF-30 P7s. These engines have a higher thrust than the TF-30 P3s that are in the F-111A version. The additional power accommodates the SAC higher gross weight and range requirements. At Carsville Air Force Base, Fort Worth, Texas, preparations are being made to receive the first of the FB-111A mission simulators. Carsville is to be the site of the Strategic Air Command's Combat Crew Training Squadron. These trainers will allow the FB crew members to fly every conceivable type of mission before taking an FB-111A aloft. The simulators are unique in that all activities of both crewmen can be simulated simultaneously throughout flight. The simulators will train the air crews in cockpit pre-flight and starting procedures, normal and emergency in-flight procedures, navigational and instrument flight procedures. Additional simulators are being built for SAC, Tactical Air Command, and Air Training Command in support of the FB-111A and F-111A, D, and E training programs. F-111C number 24 was rolled from the factory during the middle of this reporting period. This aircraft completes the sequence of 24 F-111s that were purchased under a government-to-government agreement between Australia and the United States. The F-111C, while quite similar to the United States Air Force Tactical Air Command's F-111A, has the additional 7-foot wingspan and strengthened landing gear that mark the SAC FB-111A. Cockpit arrangements in the F-111C crew area are the same as in the F-111A, with the exception that the right-hand flight control stick is removable. The RAAF crew member in the right seat will function as the bombardier, weapon system operator, navigator, and radar observer. The 24 F-111C aircraft are now at the Fort Worth facility undergoing modification. At the completion of this work, the 24 F-111C aircraft will be flown to Australia by RAAF crews. There they will become a major source of strength in the contribution of the free world's defense in that southeast area. The first production F-111E, manufacturing sequence number 160, entered final assembly in February 1969. It is the production break-in point for an improved engine inlet called Triple Plow 2. The fundamental feature of Triple Plow 2 is improved handling of the boundary layer flow approaching the inlet. Compared to the Triple Plow 1 inlet of F-111A, numbers 31 through 159, the engine inlet is nearly 4 inches further outboard, thereby minimizing the ingestion of low-energy air from the fuselage boundary layer. Like Triple Plow 1, Triple Plow 2 uses low-angle ramps, or plows, to divert much of the boundary layer around the inlet, thus minimizing the internal drag associated with ducting boundary layer flow through the airplane. The Triple Plow 2 boundary layer system has proved so effective that the splitter plate previously needed to constrain the fuselage boundary layer has been deleted, with attendant savings in weight and drag. The new inlet provides roughly 10% increase in cowl minimum flow area. The enlarged cowl accommodates the higher TF-30 P12 or P7 engine airflows, as well as the P3, and still has moderate margin for further growth in airflow. Concurrent with the enlargement of the cowl, the previous cowl translation system has been replaced by cowl blow-in doors. These are free-floating, eliminating the hydraulic, pneumatic, or electrical actuation required for CAL translation, plus the attendant control and warning systems. In ground and takeoff or landing operation, the doors float open as the engine pulls the inlet duct pressure below ambient, thus admitting additional air of relatively high energy. As forward speed increases and duct pressure approaches ambient, the doors close. They are fully closed for normal cruising and higher speeds. The first F-111D aircraft, designated as A-61 in the manufacturing sequence, entered the assembly sequence at the General Dynamics Fort Worth facility during the last days of this reporting period. This tactical fighter will be the first F-111 to have a complete Mark II avionics equipment package installed. The Mark II is a new generation of advanced avionics that will allow the aircraft to achieve pinpoint navigation and improved weapons delivery accuracy. Mark II also provides a significant air-to-air capability, including the ability to attack at very low altitudes. Microelectronic circuitry is used extensively in these advanced avionics systems to improve reliability and to reduce power and weight. Continuous airborne system self-test and built-in ground test features assure accurate and dependable performance. These advanced avionics systems include an attack radar, inertial navigation system, central digital computer complex, an integrated display set, a Doppler radar, and a stores management set. With the Mark II systems, the F-111D will perform its tactical mission more effectively than any other aircraft. The Norden Division of United Aircraft is the subcontractor for the F-111D integrated display set. Production of the IDS is underway at the Norden assembly area. Core mods, the basic electronic packages on the IDS module boards, are here shown being assembled. Core mods represent a unique method of stacking integrated circuits and discrete components to form individual electronic packages. The components are prearranged in the proper stacking order and are accurately positioned horizontally with the aid of a special alignment fixture. The fixture assures that component leads are properly placed on the core mod wafer matrix, which contains printed interconnections. When stacking is completed, the individual core mod assemblies are sent to the next stage of fabrication. Here, a pre-assembled header with connector pins is attached to the core mod. Then, additional pins are inserted into the core mod to provide connection between the left and right sides of the wafer. The core mods are then prepared for soldering. This process is accomplished on a newly designed and recently installed wave solder machine. Fully operational, the wave solder machine will be capable of handling entire module boards. Here, the core mods are attached to the rotating belt in preparation for soldering. Once attached, the core mods are directed through the wave solder operation automatically. First, the bottom halves of the units pass through a flux bath, which aids the fusing action of the solder. Then they are directed into the solder flow. The temperature of the solder is held to within 3 degrees throughout the system. This controlled environment assures a uniformity of joint, unattainable with conventional methods. After all components of the module boards have been assembled, the entire electronic package is inspected and submitted for functional testing. All integrated display sets must have a complete functional test before installation. This will assure full and complete knowledge that each component in the completed avionics hardware package will function as specified. Other F-111D avionics, including the terrain-following radar and low-altitude radar altimeter, are basically the same as those in the F-111A. Major configurations and modifications changes will follow those specifications that are being incorporated in the F-111E aircraft number 160 and on. These would include the triple plow inlet configuration, as well as several other internal design, modification, and improvement features. Thus, the F-111D is an all-weather advanced aircraft, which, with the Mark II systems, will provide the best performance accuracy and dependability available in a high-performance aircraft. During this 6-month reporting period, the production delivery rate for all F-111 aircraft has averaged 7 ships each month. The total of aircraft in all Air Force configurations manufactured through final assembly to this date numbered 162. This includes 136 of the F-111As, 24 of the Royal Australian Air Force's F-111Cs, and 3 of the Strategic Air Command's FB-111A strategic bombers. The 200th F-111 is expected to enter the assembly sequence during the next 30 days. Flights of all F-111 aircraft now total in excess of 12,000. Over 27,000 hours of flight time have been logged during these flights. Over 2,000 flights have been supersonic, with 700 flights at Mach 2 or above. 8 F-111A aircraft were accepted and delivered to the Air Force during the last month of this reporting period. The 430th Tactical Fighter Squadron, 474th Tactical Fighter Wing, Nellis Air Force Base, Nevada, received its first F-111A in March 1969. 2 other squadrons, the 428th and the 429th, have already been equipped with the Sweep Wing F-111A aircraft. As production, acceptance, and delivery of the F-111 aircraft continue to accelerate, the highly satisfactory results that have been obtained with the F-111, especially in its operational role, denote significant progress toward the modernization and strengthening of our nation's air power. Daytex numerically controlled core milling machines. This equipment is the most advanced of its type, now being used in the aircraft industry. The machines are controlled by perforated computer-type tape, which is developed by a digitizer head fastened to one of the cutting headways. This digitizer traces a simulated part pattern and converts X, Y, and Z motion into a playback tape. The perforations in the F-111C, F-111E, F-111D, and the FB-111A. Recently introduced to the F-111 manufacturing process at the Fort Worth Division of General Dynamics is a bank of 4. This is the 7th in a series of film reports covering the techniques and innovations employed in the production of the various F-111 aircraft. The F-111A tape are then read by the control unit and are translated into electrical commands which position the machine cutting head. The work platens are loaded 2 at a time. Parts to be milled are lowered from a semi-automatically controlled overhead conveyor line. As one set of beds is being made ready, the machining process can be continued on another set of beds, while finished parts are being removed from the third set. The 2 synchronous